there's like some weird, awful twist to it, which it usually is, then
we can use the videotape during the trial.
The weird, awful twist. That is the title of part 2 of today's lecture. The weird, awful twist. Okay.
So creative.
So we're gonna.
Excuse me. When's your racism?
All right.
Let's
So
go in front
we're.
of the honor committee.
Bye, Maya. Okay.
Thank you.
All right. So we're gonna do something different, and I won't know the answer to it. We're gonna start with this question. How many times, and that's really a weird way to say it, but how do we divide x plus 1 into x cubed minus 5x squared plus 9x minus 4?
Why on earth would you want to? Is it like
Great question.
we do it one at a time?
Do it one at a time, and it works a little bit strangely. So we'll start with this example, and I'll go through the process as we go. First, it's a little bit like factoring. It's a little bit like finding the greatest common factor. You have to ask yourself a similar question. And the question I'm going to ask myself is, what times x gets me x cubed? And who can tell me what times x?
X squared.
X squared. So, x squared times x would get me x cubed. So what I do is I only look at the x cubed, the first term under the divisor, and I only look at x, the first term over here, and I tell myself, what do I multiply by x to get x cubed? But here's the pain part. After I do that, I have to distribute the x squared and multiply it by both of these terms. So I multiply x squared times x, and I get the x cubed. And then I multiply x squared times plus 1, and I get plus x squared. And I carefully line that up under the x squared column here in the thing I'm dividing by. And now, just like long division, again, if you're comfortable with long division, this won't be a shock. If you've repressed your traumatic memories of long division, this will be a bit of a shock. I subtract, after I multiply x squared times x plus 1, I subtract the like terms in the columns I've set up here.
So all you have left is like negative 5.
4x squared and 4x squared.
Oh, close. I just distribute the act of subtracting. So what I have is x cubed minus x cubed. That is 0, correct. And I have minus 5x squared minus positive x squared. So what does that actually give me? It's minus 5 minus another one.
6x squared. Yeah.
Minus 6x squared. Okay. Now, I take a deep breath.
Oh, because it's a 1.
That's a 1, yes. The coefficient is understood to be 1.
Got it.
Now, I take a deep breath, and I ask myself, good, what do I multiply x times to get me minus 6x squared?
Negative 6 squared.
Negative 6x,
Oh.
because x times x gets me the x squared. So this, I write minus 6x squared, no, minus 6x, excuse me, up here, and now I multiply minus 6x times x to get me the minus 6x squared here. There's a trick from long division. It's called bringing down the next place value when you learned it in long division. Now it's bringing down the next term in your polynomial. Okay? Now, minus 6x times x gave me minus 6x squared. Minus 6x times 1 gives me minus 6x. And once again, I subtract the entire little polynomial I've created down here, being careful to distribute the subtraction. This is where most people mess up, is in the pluses and the minuses. Minus 6x squared minus negative 6x squared. Cancels out. Well put, Saul. Gives me the 0. 9x minus negative 6x gives me
15x.
plus 15x. Very good.
And then you bring down the 4.
And now I'll bring down the minus 4 at this point. Okay. Bring down the minus 4. Now I ask myself, what do I multiply times x to get 15x? 15. Positive 15. So I put plus 15 here.
Then you should get 15x.
So I go I multiply it by my entire binomial here, and this gives me 15x, which I line up with this 15x, plus 15. Very good. Then I subtract the whole thing.
I can't see.
I'll move.
Minus 11.
Nope.
Or no,
0
plus
plus
0 minus 4 minus 15. Take away 4, take away 15 more. Minus 4
19.
Oh, 19. Negative.
minus 19. Good solve. Now, at this point, we've reached the end here. And I know there's tricks in long division where you put a dot and you put a decimal in there. But in this case, we're going to go back to the first thing you learned with long division. And we're going to say that there is a remainder of negative 19.
Layla can't see.
But we're not going to leave it as remainder for long. I'll show you what we do with that in a sec. Okay?
This isn't that bad.
Good,
You
good.
made it sound like
I mean, once we're on our own, it may be a different story.
Once you
But
start,
right now,
well,
it doesn't seem that bad.
once I start telling you in advance that there's no remainder and you screw up a minus sign and keep getting a remainder, this will get frustrating. But I'm going to there's a couple more tricks I have to show you. Now let me, one of them is similar to the direct substitution we did last week. There's a reason why I left that off the test, because it's going to be a part of this starting tomorrow. One way to finally write this answer is what we've just done is we've taken x cubed minus 5x squared plus 9x minus 4. We've divided it by x plus 1. And our answer is up here. Our answer is x squared minus 6x plus 15. Now, do you remember what you did with remainders in long division when you made it into a fraction?
Oh, you turn it into decimal?
You turn it into a decimal, but one thing you did is you put the remainder over whatever you were dividing by. Remember that?
Oh, that was...
You'd get like a 4/5 or something
minus
here?
19 over x.
Yeah, so this is minus 19 over x plus 1 is how you would write the remainder in this case. And this is how you divide two polynomials.
So that's the final answer.
This is the final answer in this case. Now there's a couple of tricks and ugly things that happen, and I'll show you what those are in a sec.
But this is our homework for tonight.
Yes, this process. And I have to show you,
Okay.
and
I
this is
think
the
you
weird
should-
awful twist.
I think you should just give us certain things in like...
Small chunks.
Yeah.
Okay.
Because if you teach us anything more, then tonight will be good.
Okay, well take a deep breath. There's one more thing I have to show you or else the pacing will... Nice, but first, Carrie, yes.
So you're gonna put this online?
Yeah, try to. I should be able to.
Edit
It's easier to like hear.
It is easier to hear it.
Than watch you like write it and take it down and you have to go back and
Excellent. Yeah, I'll put this online. Yeah. So if you okay, for this part, in fact, since this will be online, if you want to like wait till tonight to take your notes on it and just
Yeah.
listen, that might be a good idea for some of you. If you're better, it all depends on your learning style.
May I ask a question?
Sure.
When are we ever going to use this? First, let's learn.
As math students or in future careers?
In future careers, or really both.
We'll
This will.
definitely use this in college. With calculus, oh my god.
You'll use it all the time with calculus, yes. It shows up all the time. There are objects whose behavior are described by equations. That there's one polynomial divided by another polynomial.
Why is there a
First
dog
we
tag
have-
hanging from your thing?
I found the dog tag and wanted to hang a heart above my board. I don't know.
Say.
Jackie, 301-983-1007, Potomac, Maryland. I'll have to edit that out. I'm not putting that out as anyone's personal dog information on the internet. Okay. Polynomial, here's where it gets a little bit tricky. I'm going to make one up. I'll do it. Okay, I won't make it that